similar shape stuff is going to be fundamental to what we're going to do next. So this is why I gave you this, just to check on a few things. Let's see if you remember. So, what do you know about similar shape? What makes shapes similar? Okay, ratio of lengths. I like how you said it that way. So ratio of lengths. And it can work in lots of different ways. Anything else we know about similar shapes? In this case. They are the same shape, just different sizes. Therefore, they have the same ratios and the same. Don't have the same area. One's bigger than the other. Same angles. Yeah? All right. Not that that matters for this, but that's just that's an important one actually. Similar shapes. So what we have to do, well, we've got lots of ways we could do this. I think what most people did was they looked at the shape and thought, what is the factor of enlargement? What do we multiply by? So in this case, I thought that BA and FE are what we call corresponding. Sorry, we have to, I know you took that, but you can't do it in my here chart. So 3 to 9, I know that's a times 3, which means everything else is times 3. So that means 7 times 3 is 21. 21. Now, just an important thing, guys, maybe it's a note to add. We have got 3 times 3 equals 9, and we've got 7 times 3 equals 21. But what we've also got is 7 divided by 3 should be equal to 21 divided by 9. Again, that's maintaining the same proportion. Is that true? Yeah, I'm not going to do anything else. They are equivalent fractions, equivalent ratios. So that's another way for me to consider it. Okay. Next question. Big here, not drawn to scale. That will become apparent in a bit. So we are going to assume that A to B corresponds to D to E. We have to assume that because it's not been told otherwise. So we're going to say that 4 times 4 equals 16. Therefore, 5 times 4 equals 20. This side would be 70 divided by 4. And I'm actually going to leave it like that. I'm just going to leave it. Because I'm not allowed a calculator. So I'm going to leave it as a fraction. It's 4 1/4, which is 4.25. It's not hard to do, but I'm going to leave it like that. Okay? All right. Trapezoids still works. I'm going to assume that this side is corresponding to that. Okay? So 1.5 times something. I'm actually going to not do something. I'm going to call it K for constant. That equals 4.5. So K is 4.5 divided by 1.5. Which does work out. It's quite easy to see actually. This one is 3. Okay? So times by 3. That means this one is corresponding to that one. So this would be 2.2 times 3, which is 6.6. This one would be, the other way, this would be 9.6 divided by 3, which is 3.2. Everyone good so far? This one Important, we do not assume it's a right angle triangle. It may well be. Okay? If it was, I could work out why without doing anything else. But we don't know. There is no symbol. Now, it might turn out that it is, but we can't assume it is. But we're going to do, we know this is the longest side, so they're corresponding. We're going to assume from the way it's drawn that 8 times something equals 20. So 8 times k equals 20. So k is 20 divided by 8. Therefore, k is 5 over 2. I'm going to leave it like that. Which means 6 times 5 divided by 2 is 15.
Oh, it's right.
It's right. All right. 25 divided by 5 over 2. Well, that's the same as doing 5 times 2 over 5 is 10. Now, you may notice that this is then a 6, 8, 10, which I remember telling you last time. One to remember is, if I divide that all by 2, I get a 3, 4, 5. So they are the Pythagorean triplets, aren't they? So I now know that these are right angle triangles, and I've shown they are, but I didn't use that at the beginning. Okay? This one. Nice and interesting. I can use a calculator this time. 5 times k is 8. Therefore, k is 8 divided by 5. I'm just going to go this one over here. So this would be 9 times 8 over 5. 9 times 8. 72 over 5 is 8.6. 14.4. Okay. Now, I took a couple of pages out. Okay, now here's the thing with this one. Ladies and gentlemen, you are talking over me. I am not here to talk over you. Okay. Again, my tip, I went round and I said, the best thing you can do for a question like this is identify 2 shapes that have been used. I know they share the same angle down there. I have to assume, although it's not on there, that those are parallel, which means this angle is the same as this one, and this one is the same as that one. So I can assume, not a very good question, not written very well, but if it was all like that, I could assume these are similar. Therefore, if that's 8 and that's 18, I'm going to do it this way. K is 18 divided by 8, or 9 over 4. Okay? Leave it like that, which means that if I know this is 6, this side here is 6 times 9 over 4, or 54 over 4, which is 27 over 2. I'm just going to leave it like that at the moment. But you're going to now tell me what that's a decimal, which is 6 point. What is it?
7.7.
The whole thing is 7.5. 27. 13.5. So this whole length, here we go, this is the important thing. This whole length is 13.5. So this is the bit that's getting confusing, which was therefore this little bit is 13.5, but subtract the 6, which is 7.5. So that bit is 7.5.
No, I got 7.
Okay. Now here's the bit challenging, right? Which is we can use our algebra now. So if I want this, if that's x,
Yeah.
some of you are head down and not even paying attention now. Some of you are talking over me. Okay, I'm going to now set up an equation which is x times 9 over 4, so 9x divided by 4, yeah, is equal to this whole length, which is 6.25
Plus X.
plus x. So I've got to solve an equation. Well within your ballpark. Should be. What do I do first?
The answer was a lucky guess.
Times by 4
Yeah.
gives me 9x's is 4 lots of all of this. So I'm going to do the 4x. What's 4 lots of 6.25? Times in both sides by 4. 25? Yeah. Easy. 25 plus 4x. Did you get this one, Ben? You don't know how to do it. Why is your head down? Why is your head down? That's my point. I'm doing it and you're paying no attention. You're like, I couldn't do it, I'm never going to do it. 25 plus 4x is equal to 9x. What's the next thing? Subtract 4x from both sides. Gives me 5x's equals 25. Therefore, 1x must equal 5.
Yeah, my answer was a lucky guess. I just assumed A and B and. I got that.
Ah, okay, hang on. That is another way, right? Isn't that not perfectly reasonable?
It says not. Well, if they're the same
But
size.
we know they are proportional, is what he says. Yeah? We know they're proportional. So 7.5 and 6 should show the same proportions because they're similar as 6.25 and whatever.
But not really.
But that's what you did. You said they showed the same proportion. If that's what you did and it works, why not?
Well, I mean,
Similar shapes, it's all about proportion.
only if A and B.
Because they're proportional, right?
Yes, but they're not gonna be. Well, the other method is.
They're similar shapes. They're proportional. That's the whole point. Yeah. Don't belittle your method. Your method worked for a reason. Stop trying to tell me why it doesn't work when it did. Okay. All right. This one. Same idea. However, proportional. We know these two angles are the same, but this side matches to this one. Okay? They're not on the same side of the diagram. This side matches to this one, and this one matches to that. Okay. Guys, I hope you're not doing your homework now. It's homework, otherwise I scrap that one and say it doesn't count. Right. I just want to say, what we're going to do tomorrow, okay? I require you, or you are required to have a good understanding of this similar shapes, sides in a same proportion, all that kind of stuff. Okay? That's why we did that today. So think about similar shapes. If there's anything you're not quite sure on, look it up tonight. I've heard a lot of things today that were interesting, like we can add to the same sides, or I wait till you pack up and then I carry on talking. Okay, it's still recording so you can watch it on the video. Adding to all the sides does not work. Subtracting does not work. we're maintaining proportions. Proportions can be done from one shape to the other or within the same shape. Those are important aspects for tomorrow's lesson, getting similar shape. So if there's anything in here that you weren't quite sure about, have a look at it tonight, ready for tomorrow. Okay? When's your clinometer due? Thursday. I do have another piece of homework set up on my iMaths for you. Okay, I'll put it on management for when it's due, and you don't need to do it tomorrow. Put it on, I changed my plan, but it will be there. Okay, thank you. Have a good rest of your day.